This is example 5.1.1. It says draw a free body diagram and determine the net force for the soccer ball as the action in the picture is occurring. So the first thing we want to do is we want to represent our object, which in our case is the soccer ball, as a dot. Then we want to say, hey, is this thing on Earth or is it subjected to some sort of gravitational field? And in this case, yeah, the soccer ball is on the Earth, so what we can do is we can draw an arrow down and we can go ahead and label that FG for the gravitational force. Now, since the soccer ball is not moving up or down, we have to say, okay, because of that, there has to be a force upwards as well. And remember, the force that's exerted upwards to counteract gravity when an object is at rest on a surface is called the normal force. Now we can take a look at these individual forces. So the first one we have is we have a force that's 75 newtons that's subjected to the right. Now I understand that the arrow is pointed towards the ball this way, but we always do this. We always say this is the direction right there. So you can say 75 newtons right there. And then the force to the left is 125 newtons. So this right here gives you a little bit better idea. We drew this a little bit backwards. This gives you a little bit better idea of what the different forces are. We can say that the normal force and the gravitational force, they're equal, and so they're going to cancel each other out. So when we're trying to find the sum of the forces, really all we're left with is the left force and the right force. So what you do is you take the larger one, which in our case is 125 newtons, 125, and we have to subtract 75 because it's in the opposite direction. And what we're ended up with is 50 newtons. And then the direction is really important in this case. It has to be left. And the reason why it's left is because the leftward force was greater than the rightward force.